Hello, in this video we are going to look at shader modules for Vulkan. So we're going to have a couple of shader files. We're going to have a vertex shader file and a fragment shader file. Vertex shader file, you can think of it, the structure of what you're drawing, and fragment shader, how it's going to look, color. And we're not looking at texture at the moment, but like that will be covered there as well. So we need to actually create those shader files. We're creating them momentarily. We will obviously also be implementing them in code, and to actually use shader files in Vulkan, you'll need to compile them. So they'll be compiled into byte format, and they won't be human readable. But what we can do is actually write them in a more sort of C syntax, like essentially like GLSL, and compile them into the format that we need to use to read them in. So that's fine. We can still write them in a human readable format, but we'll just need to compile them. So on Linux and Mac, process will be slightly different. I may or may not create a video because essentially it's almost the same, and I'll explain the part that is different. So first of all, let's write the shaders. I'm just gonna write them in, close that, in a separate text editor. Just keep it. I'm gonna open it in Sublime. And what I'm gonna do is where the main.cpp file is, let me close, reduce the size a bit. I'm gonna create a new folder here called res, so that's going to be short for resources. In there, I'm gonna create a folder called shaders, and this is where all our shader files are gonna go. So the first one we're gonna create is, like I said, the vertex shader. So let's start. So we're gonna put a version, so version 450, and for layout, location equals 0, and we're going to put out vec3 frag color. So this will be going to a separate file. This will be going to the fragment, the frag shader, and semicolon. Then we'll say vec2 positions 3 equals vec2, and I'm going to put vec to 0.0, negative 0.5. So this is just going to be basically the position of the 3 points on our triangle, and the screen is going to range between -1 and 1. So the left side will be -1, the right side will be 1, and the same system for up and down as well. So this will make sure it doesn't go all the way to the edges, but it's not super small either. Okay, so put a comma for vec2 and put 0.5. Again, feel free to modify these. I highly recommend that you do, and try and create some other type of triangle, maybe like an isosceles triangle. And vec2 negative 0.5 and 0.5. Okay, so now that we got that, we're gonna have something kind of similar for colors. So I'm gonna say vec3 colors 3 equals vec3, and parenthesis again, not curly brace, for a semicolon, and put vec3. And I'm just gonna, because we're gonna need 3 of these, it's gonna be 1 for each corner of the triangle, and then basically the color will be interpolated throughout the entire triangle, or colors. And for this, again, we need 3 values: red, green, and blue. Hence, vec3 and not vec2. So we're going to put 1.0, 0.0, 0.0. So that's red. And we'll put, green now. So we'll just put 0.0, 1.0. You don't have to put green, you put whatever you want, but we're just going to showcase the interpolation. You might want it all one solid color, then you just have them all, let's say 1.0, 1.0, 1.0, so they'll be red, for example. Now, as like any sort of C++ style file, you'll need a main entry point. So I'm going to say void main, open close parenthesis, open close curly brace. You just put gl underscore position. So now we're going to calculate the position of our object. So we're going to put vec4, and you just put positions gl gl underscore vertex index, comma 0.0, comma 1.0, semicolon. Finally, I'm gonna put frag color equals colors gl underscore vertex index, and that's it. So we can save this out now. So we're gonna save it as shader.vert, and I've already got it navigated, but again, if you just go to your project, res shaders, and just put it here. So I'm going to call it shader.vert, like so. And now we're going to create the fragment shader. Fragment shader is a lot simpler. So new file, hash version 450, which is 4.5, layout location equals 0. If you've done OpenGL before, which I highly recommend that you should, if you have this will feel right at home. Frag color, so this is referencing this right here, so make sure that is same name. So I'm going to say layout location equals 0, and this is what's going to be outputted, and vec4. So remember, in the graphics pipeline introduction video, the previous video, I talked about the different stages. So once it's gone from the vertex shade, the fragment shader, it'll just be passed on to the next part of it, and we don't have to worry anymore. Next, we're just gonna have a very simple main. I would say out color equals vec4 frag color 1.0. As we go into more complex stuff like textures, these files will change, but for now, this is all we need. And I'm going to call it shader.frag. Okay, so now I'll leave that open because we might still need that. There's a few things I still want to do in there just to show you. We'll need the GLSLC that we installed right in the setup video, which is the Google Shader compiler. You could use the built-in one, feel free to use that, but we're using GLSLC one. And so what we're gonna do, you gotta find where you installed it. I know I installed it in D development Vulkan, and then you go to BIMFADE 2. So this is the case for Windows. If you're on Linux or Mac, just figure out where you installed it. Again, obviously you will know that when you install this, so it's probably best to make a note of that. And just go there, find the GLSLC file. Obviously it'll be .exe on Windows, it'll be a different extension on Mac and Linux. And what I would recommend is copy and paste this where these files are. There's different ways of doing it. You could just drag the shader files onto here and do it, it'll pump it out. I like to have it here instead of having to open this up again and again. So what we can literally do is just do this, and all goes well, it'll produce that. So I'm just going to delete it because if I do the vert one, it'll also produce a a.spv. So as you can see, it's not producing the a.spv. There's a very good chance I've made a mistake in the code, whereas this doesn't show me the mistake that I've made if I have made a mistake. So what I recommend is that you open up command prompt. You can create a batch script file to actually do them all in one go. Feel free to do that as an extra task. I'm just going to show you manually like this, and the process is essentially similar on Linux and Mac. Once you've got the GLSLC compiler, you just drag and drop that onto there, then press space, then drag and drop, let's say, that onto there, and click enter. And my thinking, nothing's there. It's because it will automatically generate it in the folder that your terminal or command prompt is pointing to. So if I type in ls, it's producing there. We don't want that. So you can either do one of two things. You can either output it here specifically, by specifying it, or just change directory to this. That's what I recommend. Again, Mac and Linux, same thing. Type cd, drag and drop this on, get rid of that because we just want the actual folder, and it doesn't change it. This is just a Windows problem, And to change it, you just type in the letter name if it's not on the C drive, then colon. So for me, it's E colon, and now it's changed it. And you can go within the E drive. If you want to go back to C drive, you'll have to do the same system. Okay, so now if I was to just say gl slc.exe space and shader.frag, is produced it right there. I'm going to delete it because what I want to do instead of that, I'm going to name it a certain file. So I'm going to say space dash o, not dash 0 dash o. That's the output file, and you can specify a direct path as well. But because we're here, you'll just pump it out where we want it. That's fine. And the name I'm going to specify is, this is the frag file, and I'm going to say frag.spv. Boom, done. Now let's do the same for the vertex file. .exe shader.vert dash o vert.spv. Okay, so we get an error. So it is saying line 5 error, syntax error, unexpected right bracket 1 error generated. So let's say line 5. Line 5. Now so let's go here. Line 5. It was the vert file. We're gonna put vec2, and now if I go back and if I run it, we should hopefully move it over a bit. Should hopefully work now. There we go. We got the vert and frag SPV files, and we can actually use them in our code now. So this way, it actually shows you the problem. If you just drag and drop, let's say, like that onto there, you'll try and do it. It's obviously going to do it now because I've made, the change. But if I didn't make the change, it would just not show you the error because the command prompt will shut down straight away. So this is a better way of doing it. Like I said, you can create a batch file. So you just, let's say, double click it and it compiles all of the shader files. That can be very beneficial if you have a more, a bigger project with maybe tens or even hundreds of potential shader files. Just, compile them in one go. Feel free to have a go at that. I'll minimize this. We may still need it. And now we can actually get onto the code. So let's actually go into the code and implement it. It's not too complex, to be fair. The first thing we need to do is put a new hash include f stream, and this just allows us to read and write files, basically a file handling include. So next thing that we want to do is go down to where we created the method create graphics pipeline. We actually want to implement that now because before we didn't actually implement it. So scroll down. It's just an empty function at the moment. So it's going to say auto vert shader code equals read file, and this read file method does not exist, and we'll be creating it. So we'll create it momentarily. You specify the path of the file. We'll put res/shaders/vert.spv. So that's the vertex shader. Let's copy and paste that, and we're going to change that to frag shader code. And we need to do the same thing. Just read the frag.spv that we compiled. Now what we're going to do is create shader modules for the vert. The vert and frag shader code. To do that, do vk shader module vert shader module equals create shader module. Don't worry, this method is something that we'll be implementing as well. And you specify the contents of the file, which is automatically read into here. And we're going to copy and paste this. I will hide that. So we have the same for frag. Okay, so now what we need to do is create a pipeline shader stage for the vertex shader and for the frag shader. It's pretty simple stuff. We do vk pipeline shader stage create info vert shader stage info curly braces semicolon, and we'll just put vert shader vert stage info dot s type equals vk underscore structure underscore type underscore pipeline underscore shader underscore stage underscore create underscore info. Okay, so now we're going to say vert shader stage info dot stage equals vk underscore shader underscore stage underscore vertex bit, and I'm going to say vert shader stage info dot module equals vert shader module semicolon. Almost done for the vertex shader. Say vert shader stage info dot p name. So this is basically the name of the main function, and we call it main, so we can just put that. If you call it something else, you just specify it here. And now what we're going to do is copy and paste this because it's very similar for the fragment shader. It's the same pipeline shader stage info. I'm going to call this frag, and we're going to change all these to frag as well. Make sure everything else is all correct. We need to change that to fragment bit. Change that to frag shader module. I think we're all good to proceed on to the next step. Okay, so we're gonna actually create the shader stages now. So vk pipeline shader stage create info shader stages equals, and we specify the vertex stage info first, then the frag shader stage info next. And now we're just going to do some cleanup and destroy the shader modules. So we just put vk destroy shader module, and first of all you specify the device, then you specify, because obviously it's gone to the graphics card, the shader module, and then some optional callbacks. We're not going to put no pointer, but again feel free to put some callbacks. And now we're going to put vert shader module. Next, what we need to do is implement that create shader module method. So if we do that, so I'm going to say vk shader module, so that's what it's going to return, create shader module, and this is going to take in one parameter. So it's going to be a vector of characters ampersand code. So this is going to be the bytecode from the shader file. And now what we're going to do is say vk shader module create info and I'm just going to make sure it's easy to do this mistake. Make sure I've got, that's basically just for me, but make sure there's curly braces where there should be and there's parentheses where there should be. Okay, it's looking all good to me. And now we're going to say create info dot s type equals vk underscore structure underscore type underscore shader underscore module underscore create info. So now I'm going to say create info.code size equals code.size, and this is a function, and we're just going to set the p code now. So create info.p code equals reinterpret cast, and I'm going to cast it to a const unsigned int again. If I have uint32 underscore t in the code anywhere, that's just what it's referring to. And it's to a pointer of this, and we're going to say code.data, and I'm going to say VK shader module and say if VK create shader module underscore device, specify the create info, and then some optional callbacks. So we're going to put no pointer, specify the reference as shader module. I'm going to say if this isn't equal to VK underscore success, not VL, VK underscore success, then we'll throw an error. We'll throw std runtime error failed to create shader module. And we'll put return shader module. Okay, so that should fix all these errors except for the read file. So now what we're going to do is, I think you guessed it, we are going to go ahead and implement that read file method. So we're going to put it way down below. We'll put it after the check validation support method. So we'll put it down here. So to do this, pretty simple stuff, to be fair. It's just reading the contents of a file. So it's going to be static, and it's going to return a vector of characters. That's all a file essentially is. And it's going to take in a constant string, which we'll call file name. And first of all, we're going to create a if stream object. So if stream, so this will allow us to get the content called file, and we specify the file name and what we want to do with it. So std, so basically the open mode, std : input output system ate, and you OR it with std : ios binary. That's the type of file that it is. Okay, so if file.is open, if it's not, if it doesn't open, then we're going to throw an error. And it could be not open for many reasons. The main one, you haven't specified the path correctly, or it's just not there, or the name is incorrect. So always bear that in mind. I'm going to say failed to open file, and I'm going to say size underscore t. Again, you could just replace that with unsigned long. Yeah, let's do that. Unsigned long file size equals unsigned long file dot telg. And now we're gonna actually get the create a buffer for the contents. So we're gonna say std : vector char buffer file size. So say file.seek g0 semicolon file.read buffer.data file size file.close and return buffer. Okay, so we should be good to go now, actually. So if we give it a run, let's see what happens. So you'll first just go through all of the extension stuff, and at the end, if there's no errors, then we're all good to go. Let me just maximize that. That's fine. Just out the anisotropy which we had before, and we're all good to go. So let me show you if so. We're all good now. We're all done for this tutorial, and in the next video we'll carry on with the graphics pipeline. If I scroll up to where we actually specify the files, if let's say I was to put say 5 there, that file does not exist. Or if I was to change the path, let's see what happens. It still compiles. This will be a compile time error if we're gonna get one. So the application ended because a error was thrown, failed to open file, which is in the read file method. Okie dokie. So what I want to now show you is last thing. Close that. Is you see these resources here? This is fine when you're just debugging. If you actually have the exe, it could be in debug mode, it could be in release mode, it could be in 32-bit mode, 64-bit mode. We are in x64 and we are in debug, and here's the exe that gets produced. And as you can see, the timestamp is just a minute ago. If I open that, it goes through all that stuff, but then it just stops. That stop is just because there's no. It just basically ends. What we're gonna do is right at the end, I'm gonna put actually, I think we're gonna mess up there. It could be here, won't it? So system.pause. Yeah, I think this is the one. Let me give that a build. Okay, so now let's give that a run. Okay, so as you can see, it's paused in now. It says failed to open file. Why is it failing to open the file? Because we already had it. It's because if we want to run it from the exe directly and not through the IDE, you need to put the resources and any of the resource that's linked to it there. So if we go to Vulkan tutorial, don't need external libraries because they're just for compiling purposes. But if I grab that now, go to x64 again, yours could be in debug, which would be 32-bit mode. If there's a release folder here, that'll be release 32-bit mode. If it's x64 folder, it's a 64-bit. This is debug 64-bit. If there's a release folder, that'll be release 64-bit. Open that, paste that in, and let me actually close down what we've already got. Still failing to open the file. Strange. Let me go over here. Feel like I didn't rename it. Oh yeah, I didn't rename it. So if I'll save that, give that a build, wait for that build to succeed. Build has now succeeded. Open this up. As you can see, we don't get that error anymore. We'll close that down. But if I was to, let's say, delete that folder and open it up, we get an error because the shader files are no longer there. So that is it. What I'll do is I'll remove the system pause because we're running it in the IDE anyway. We don't need it because the IDE keeps the command prompt open, and terminal if you're on something like Mac or Linux after you run it and it's got to the end. So that's it, and that's how you implement shader modules. Obviously, over the next few videos, we'll continue and we will eventually get to drawing a triangle. Next, we're going to look at fixed functions. If you have any questions, feel free to join the Discord group. There's a link in the description. Over 4,600 members on there now. There's a Vulkan channel, so check that out. There's also a link to the GitHub page in the description. If I said destruction, my bad. In the description, and you can see all the source code with working projects for each video as well. So thanks for watching, and I look forward to seeing you in the next video.